Ever wondered what really happens when you move your mouse, click, and select a file on your computer? It seems so simple, right? A little blue box appears, and that's it. But underneath that simple action, your computer is performing a series of incredibly fast and precise operations. Today, we're going to pull back the curtain and explore the secret life of a mouse click. You might think it's just about pixels on a screen, but the reality is much more fascinating. It's a story about hardware, software, and the clever bit of digital make-believe that powers our entire computing experience. So let's start with the basics. You move your mouse. How does the computer even know where your hand is? Inside your mouse, there's a sensor, usually an optical or laser one. It's like a tiny, super-fast camera, taking thousands of pictures of the surface it's on every single second. By comparing these pictures, it calculates the direction and speed of your movement. This information, like moved 10 units right and 5 units up, is sent to your computer through the USB cable or a wireless signal. Your operating system, whether it's Windows, Mac OS, or Linux, receives this raw data. It then has a special piece of software called a driver that translates these 10 units right signals into the smooth movement of the cursor you see on your screen. The little arrow isn't just moving. It's being constantly redrawn at new coordinates based on the flood of information coming from your mouse. Now for the main event, selecting a file. Let's think about your computer storage like a hard drive or a SSD as a gigantic, meticulously organized warehouse. Every file, from a photo to a program, is a box stored on a shelf somewhere in this warehouse. Your operating system is the warehouse manager. It has a master list, a file system that knows the exact location, size, and name of every single box. When you're looking at your desktop or a folder, you're not seeing the actual files. You're looking at a graphical representation, a convenient map provided by the warehouse manager. The icons are just pictures that represent the boxes. So, when you click and drag to select a file, what are you actually doing? Here's a great analogy. You're not moving the box. You're telling the warehouse manager to put a special tag on it. Selecting a file is like saying, "Hey manager, this box right here, I'm interested in it." Tag it for a potential future operation. The highlight, that blue rectangle that appears around the icon, is just a visual indicator of this tag. It's like the warehouse manager shines a bright spotlight on the box you pointed at. It's the Graphical User Interface, or GUI, confirming, got it. This one is now selected. Internally, the operating system changes the state of that file object in its memory. Before you clicked, its state was not selected. After you click, its state becomes selected. It's a simple binary switch, a flag that flips from 0 to 1. If you select multiple files, the manager just puts tags on all of them. The visual highlighting is purely for your benefit. The computer doesn't need the blue box. It knows which files are selected because it has a list of everything that's been tagged. This is a fundamental concept in computing, the separation of internal state from its visual representation. The truth is the tagged list in memory. The screen is just a helpful illustration of that truth. This is why you can do things with selected files. Once a file is tagged, you can issue further commands that apply to everything with a tag. Think about it, you select a group of photos. Then you right-click and choose Copy. What you're really telling the warehouse manager is, for all the boxes that currently have a tag on them, prepare to make a duplicate. The computer doesn't have to ask you again which files you meant. It just checks its list of tagged items and proceeds. The same logic applies to deleting, moving, or renaming files. The selection is the crucial first step that tells the computer what you want to work with. Now let's escalate things. What about the double click? A single click says, "I'm interested in this." A double click is a much more definitive command. It's like going from tagging a box to telling the warehouse manager, "Okay, that one I tagged, I've confirmed the order. Ship it out now." In computing terms, a double click is the default open action. The operating system looks at the file type. Is it a text document, a picture, a song, or a program? Based on that, it knows what to do. If it's a photo, it sends it to your default image viewer. If it's a song, it launches your music player. It's a pre-configured shortcut that says, do the most common thing with this file. The timing is critical. Your operating system has a specific time window, usually around half a second, to distinguish between two separate single clicks and one double click. If the second click arrives within that window, it's interpreted as a double click. If it's too slow, the computer just sees it as you selecting the file and then selecting it again. You can even change this double click speed in your system settings to match your own rhythm. It's a simple but brilliant piece of user interface design, so let's take it to the final step. What happens when you double-click an application, a program file? This is where the magic really happens. You've just told the warehouse manager to ship the program. But what does that even mean? Shipping a program isn't like opening a photo. The operating system has to perform a complex sequence of actions. First, it reads the program's file from the storage, the hard drive. It finds the box in the warehouse, but it doesn't just look at it. It needs to bring the contents of that box into the main workshop, which is your computer's RAM, or random access memory. RAM is like the workbench of your computer. It's much faster than the warehouse storage, but it's temporary. Anything on the workbench disappears when the power is turned off. The operating system acts as the ultimate project manager. It allocates a specific area on this workbench just for your program. It then starts copying the program as code and its initial data from the slow warehouse hard drive to this super-fast workbench, RAM. This process is what you're seeing when a loading screen or a spinning wheel appears. The computer is busy setting up the workspace. Once the essential parts of the program are loaded into RAM, the operating system hands over control to the CPU, the central processing unit. The CPU is the master craftsman, the brain of the whole operation. It goes to the program's starting address in RAM and begins executing the instructions one by one at a mind-boggling speed. These instructions tell the CPU what to do. Draw a window on the screen, create buttons, listen for more mouse clicks and keyboard input, and perform the program's actual function. Whether that's calculating a spreadsheet or rendering a 3D world in a game. And just like that, the program is running. It has its own space and memory, it's being executed by the CPU, and it's interacting with you through the operating system. From a simple twitch of your hand to a fully running application, it's a beautiful dance of hardware and software. The mouse sends movement data. The OS moves the cursor. A click tags a file by changing its internal state. The GUI shows you a blue box as confirmation. And a double-click initiates a complex process of loading that file from storage into memory, where the CPU can finally bring it to life. So the next time you casually select a folder or launch a program, take a moment to appreciate the incredible, invisible logistics operation happening under the hood. It's a testament to decades of ingenuity that have made using a computer so intuitive, we don't even have to think about it, but now you know the secret. Thanks for diving deep into the world of computing with me today. If you found this interesting, don't forget to hit that like button and subscribe for more tech deep dives. Let us know in the comments if there are any other everyday computer mysteries you'd like us to unravel. See you in the next one.